What if our whole understanding of ancient Indian civilization is off? And not just by a little bit, but by tens of thousands of years. Today, we are diving into the incredible multidisciplinary research of Rupa Bhaty, a body of work that truly threatens to rewrite the very first chapters of human history. So this explainer is all based on the work of researcher Rupa Bhaty. And as you can see from her own words, her goal is to take these really complex, challenging ideas and make them accessible to everyone. She combines archaeology, genetics, and a pretty unique method of astronomical dating to propose this radically older timeline for India's past. But before we get into that, let's quickly set the stage with the story we've all been told. So here's our game plan. First, we'll lay out the conventional timeline. Then, we're going to look at the three big pillars of evidence that challenge it, what we're finding in the ground, in our DNA, and in the stars. After that, we'll put the two timelines side by side to see just how different they are. And finally, we'll step back and think about what this all could mean for our understanding of history. Okay, so to really grasp why this new research is so provocative, we first need a baseline. Let's talk about the widely accepted story of human history, especially as it relates to India. You know, the mainstream view goes something like this. Modern humans migrated out of Africa around 70,000 years ago. Way later, you see the rise of big urban centers like the Indus Valley civilization around 3300 BCE, and the composition of the Rigveda, which is one of the world's oldest scriptures, that's usually dated to around 1500 BCE. These dates, they're pretty much the bedrock of our current understanding. But as we're about to see, some new evidence is starting to shake that very foundation. Let's move on to our first line of evidence. You know, the story of our deep past is often literally unearthed, piece by piece, from the soil right beneath our feet. And in India, well, the ground is telling a very old story. The subcontinent is actually home to some of the oldest tool-making cultures on the planet. The Madrasian culture, that goes back an astonishing 1.5 million years. The Sawanian is at least 500,000 BP, and BP just means before present. But look, this isn't just about simple stone tools. At a site called Rewat 55 in what's now Pakistan, there's evidence of actual architectural foundations dated to around 45,000 years ago. That's a huge sign of modern human behavior. And then there are the Bhimbetka rock shelters in central India. They show signs of continuous human habitation for at least 700,000 years. Let that sink in. This wasn't just a brief settlement. It's an epic, unbroken chain of human presence stretching way back into the Ice Age. And inside those very same caves, the art is just stunning. Some of it has been dated as far back as 37,000 years. And get this, it depicts things you would never expect from that long ago. Horses, wheels, even chariots. And it's not just on land. Off the coast, submerged structures are hinting at whole lost civilizations. In the Gulf of Cambay, pottery has been dated to over 20,000 years old. And along the Konkan coast, there's a massive 24-kilometer-long man-made wall, now sitting under the sea from 8,000 years ago. So we've looked at physical artifacts. Now let's pivot to the evidence that's written inside our own cells. Genetics offers another fascinating and potentially disruptive piece of this incredible puzzle. Okay, so central to that standard out-of-Africa story is something called the L3 mitochondrial lineage. The theory is that a small group of people carrying this specific genetic marker left Africa, and from them, pretty much all non-African populations are descended. It's a foundational idea in human population genetics. But researchers like Dr. Premendra Priyadarshi, who's cited in Bhaty's work, are asking a really bold question. They've traced the L3 lineage back to its genetic parent and forward to its child lineages. And they argue that the greatest diversity, which usually points to the place of origin, isn't found in Africa, but in India. So their question is profound. What if the L3 lineage first appeared in India and then migrated out to the rest of the world, including back into Africa? It's a hypothesis that completely flips the script on early human migration. Now we get to a really fascinating part of this research. What if ancient scriptures contained a kind of hidden clock? This is the whole idea behind archaeoastronomy, using the predictable movements of the stars to date the astronomical observations that were recorded in these ancient texts. The science behind this is a phenomenon called the precession of the equinoxes. Just think of the Earth like a slowly wobbling top. Because of this wobble, over a massive 26,000-year cycle, the star that marks the sunrise on the first day of spring, that's the vernal equinox, it changes. So, if an ancient text accurately describes which star or constellation was in that exact position, you can basically calculate precisely when that observation was made. It's like a celestial clock.
Okay, so using this method, Rupa Bhaty and others have pulled a series of just staggering dates from India's secret texts. An observation in one text points to 2900 BCE. The epic Ramayana is dated to 12,209 BCE. Another mentions an event that could only happen around 19,000 BCE, and it just keeps going further and further back. 28,000 BCE, 34,500 BCE, and this all culminates in a date for the earliest layers of the Rigveda of over 50,000 years ago. I mean, a Rigveda that ancient would imply a level of abstract thought and oral tradition far, far earlier than anyone currently accepts. It would fundamentally alter our timeline of human intellectual development.
So, let's put all of this together. What does this new, radically older story actually look like when we place it right next to the one we all started with?
The contrast is, well, it's stark. On one side, you have the Rigveda at 1500 BCE. On the other, at over 50,000 BCE. The conventional timeline sees the first major cities popping up around 3300 BCE. This new evidence points to organized settlements with pottery over 20,000 years ago. This isn't just a minor adjustment to history, it is a fundamental re-envisioning of the entire timeline.
Now, it is really important to look at this with a balanced perspective. The strength of this new proposed timeline is that it pulls together converging data from three totally different fields: archaeology, genetics, and astronomy. But the challenges are also significant. It would require overturning a century of established consensus. Mainstream scholars argue that the interpretations of these ancient texts can be ambiguous and that we need a lot more archaeological evidence to back up these claims.
So this research doesn't just ask us to reconsider a few dates on a timeline. It's asking us to reconsider how we even think about the deep past itself.
And, in the researcher's own words, this is really just the beginning. She says we are at a nascent stage of understanding how to decode the immense amount of information, geographical, astronomical, cultural, that might be preserved in these ancient texts. This really frames her work not as a final answer, but as the start of a whole new investigation. And that really leaves us with one final question to ponder. Is our history a fixed, settled story that's already been written in stone? Or is it a dynamic, ongoing investigation, constantly being revised by new evidence and new ways of seeing? The work of Rupa Bhaty suggests it's very much the latter. It reminds us that the story of our past might just be far older and far more mysterious than we ever imagined.